Thanks for introduction. My name is Maciej Brzezniak. I represent a team of several people from those three listed here, working at PSNC on enabling data management services. One of them is based on Seafile. Our target is to actually, and in the same time, challenge to address the needs of a countrywide service. So it's actually challenging enough by itself. In this talk, I'll try to show you some specifics of Seafile, present why we believe it's able to really stress I/O part as a storage part. We'll also show what is the idea behind the box service, Pioneer box service. We showed some test results and some observations. So the challenge is well known. Maybe there's no need to repeat it. But we see three different things which people expect, and they sometimes are kind of contradictory. One is volume of the data you want to store, the other is performance, and yet another is the ease of use. And we think that we see already that even in a small-scale service, which we run since 2 years almost, there are already users who treat the Dropbox-like service as a target for backups or for really large data, like for instance, people storing 500 gigabytes per user, or our PR department who stores 400 gigabytes of files and served files within WordPress embedded from Seafile. Yeah? Some crazy use cases happen. Why we decided for Seafile? The reason is that it's a really specialized solution. We find it designed in a way that it's really interesting and promising alternative to Dropbox or other large-scale things. We find it very reliable and effective. Reliability results, among other, from the data model and synchronization algorithm, which is very robust. And it's effective thanks to algorithms and also thanks to the low-level implementation. It speaks to different backends, including file system and object stores. And we will be comparing these backends. What is specific about Seafile is that it's like racing car. It's not multi-purpose, but it's really fit for purpose. So it's not having too much add-ons, applications, and so on. But in sync&share, it's really fast and reliable. That's why we went for it. So it was already shown by Jonathan, but the data model and synchronization algorithm are very important factors. This is all based on snapshots of the namespace, not per file versioning, and only the differences between particular snapshots are sent between server and clients. This is very important because it saves network bandwidth. It also makes the whole synchronization algorithm very effective. Even making simple tests, we can see that Seafile really keeps pace with different older solutions. This is actually a large files test made on the single server in the community version, so the open source one, 1 year ago. And we can see that, that for the large files, it's OK. But for the small files, Seafile actually really beats the other solutions. Like you could see that files per second performance is something like 20 times better than the other open source, the other popular solutions. In that test, we used the Linux kernel source as a stressing test set or data set. It was run on top of a single server with 2 CPUs and disk array, fiber channel disk array attached direct to the backend. OK, and if you see that these results, even from the single server perspective, are very good, very promising, you can expect that in the clustered setups, when you target the high scale, because the Seafile itself is not a bottleneck for performance, it doesn't have too much overhead on the CPU. It doesn't require a really strong database engine because it's really keeping minimum data into database, only some information on shares and user profiles, and actually the metadata are stored on the storage backend. It really has potential to stress this storage backend. And I personally have some storage-oriented attitude because I'm originally was working more on backend storage systems. That's why this aspect is also interesting for me. So when we want to provide a countrywide service, we really have to take into account and make a conscious decision what kind of backend we will use, because this is important for performance, for reliability, but also for long-term costs. So in the same time, we also want to exploit the real potential of the solution, and we also want to achieve the situation when we can still use the effect of the scale, because we're also in the HPC center, having large storage, so we would like to reuse the resources for different applications, including sync and share. We're kind of well positioned for providing such a service for a country because we are UNRIAN at the same time, so we provide the network. You see some numbers here. It's actually spanning the whole country, having some broadband interconnects to the European networks. We already address storage systems since some years by providing the production service for backup archive. And we also have a countrywide cloud computing services. But all these services need some, I mean, they are currently used, but we also are pressed by users by this aspect which I mentioned. They expect ease of use. That's why we went for sync&share stuff. Okay, and one important aspect is also that we have large resources related to HPC, and attached to this cluster, which I'm proud of being able to show here, is that we have also quite large storage systems at the backend, such as, for instance, 6 petabytes Scratch based on Lustre and 5 petabytes GPFS based homes based on GPFS. And actually, GPFS is one of the interesting options for deploying Seafile. And here, I'm trying to analyze how you can actually make it. You can put cluster Seafile server on top of GPFS using GPFS client and SD client and speak to the servers. But this, of course, costs you because for every Seafile server, you would need a GPFS license. You can also go the easier way, and this is the way we went in this test, that you have GPFS cluster, NFS servers on top of it, and you can then have any number of Seafile servers you want, of course, with some added latency. And the other option, yet another option, is to use Ceph as a backend. Seafile is implementing the native Ceph interface plugin based on Librados. Okay, maybe I will not go through all the details of the test, but let me just point that we tried to find a comparable configs between GPFS and Ceph. So we decided this may be the number of disks should be kind of reference point, and in disk array we're using for testing, we've got 120 drives, while in the servers and under Ceph we've got something like 96. Okay, and in this test, we're using a load balanced setup, where you can set up a load balancer in front of Seafile servers. They work independently of each other, keeping only small data for session information and so on in the memcache. So architecture scores horizontally, and we can really see it also in the tests. So concerning test results, we did two kinds of tests. The first one is transferring large files into the Seafile server and back. And you could see the blue lines are for GPFS, the red ones are for Ceph. You could see that in case of large files, GPFS actually in our configuration is it's somehow faster than Ceph as a backend. Of course, all this data go through Seafile client and server. And you can also see that typically there might be some specific of implementing the interface to the backend. This is the reason why we, at this case, see that uploads are a bit faster than downloads. But we're analyzing the situation with developers, and we perhaps hopefully come to the conclusion. But more interesting results appear when you start to do small files tests. This is actually, we believe that this is actually the killer case for sync&share, but because the most users actually have small files. So we run a test where you've got 45,000 100 kilobyte files in each client, and we run server for one client, which is named here 1 upload, 1 download, and 12 uploads, 12 downloads, which number here means number of clients, Seafile clients speaking to the Seafile server. So you could see that with GPFS, we of course benefit from having more threads, both for upload and for download. But for Ceph, really something interesting happens. After uploading the data and trying to download it, we see that the performance really jumps like crazy. We think that the benefit here is that we've got, in case of Ceph, we've got a lot of RAM. Actually, each of the Cephs, we've got eight Ceph servers. Each it has like 128 gigabytes RAM. So it's almost 1 terabyte RAM, which Linux aggressively uses for caching. And in case of downloading the data to the Seafile client through server from Ceph, we see that this really helps. I mean, apparently this data all sits in the RAM. We even tested this 5 times to just confirm the results if we're not wrong. But in that case, we really can see that in case of applications such as sync&share, the parallelism which is enabled in Ceph, because this is really decentralized architecture, it is really bringing benefits, because you can process multiple requests in a parallel. Perhaps the per request latency is higher than in GPFS, but in general the parallelism you can get is helping you. It's actually what I said already. And we also confirmed this observation by making pure, let's say, no Seafile tests from this Seafile server. We just uploaded data to NFS, actually GPFS, and also Ceph, and we have seen the same actually trends. So what happened to Seafile also happened without Seafile. So when you combine all these results, you could see that even for the single, so these two columns show the single server performance from last year, from test run last year. It's actually, in terms of files per second, the Seafile is really fast. If you add parallelism and if you add multiple servers and really parallel backend, we can go even higher, like from 900 files per second for download to this number. Of course, with help of RAM memory. In that case, we have a bit faster, bigger files, so the initial performance is slower. But if you compare this by files per second, and if you combine upload and download, it's actually much faster. Okay, so conclusions for Seafile are that in the area of Seafile are that it looks like Seafile is really well written and doesn't constitute any bottleneck in terms of maybe not any, but doesn't constitute a serious bottleneck in terms of I/O performance. It performs 20 to 30 times faster, even in the community version. With professional, you could see the setup, the speed up, and it actually is able to use the power of object stores, which are enabling this parallelism which I mentioned. There might be some improvements on the way how able is the Seafile to exploit the backend, but it's even in the current state, it's much faster than the other solutions. And the conclusions for the backends, more generalized, are, at least for our test, it looks like the backend for sync&share really should support high level of I/O parallelism. Even if, so for instance, Ceph is good in it, good here, because even with the per thread higher latency, thanks to parallelism, it's able to provide good performance. And GPFS looks to be better in cases where you have single threads and their latency, the per thread latency, is more important. The good thing about both solutions is that they could be both reused for both in the same time running Seafile on top of it and other applications. Like in Ceph, you can have some part of Ceph attached to objects and objects for Seafile, and then serve RBD volumes to your machines. In GPFS, you can also have such a hybrid approach. By the way, recently GPFS started to support a Swift frontend. So it's also interesting. People try to actually combine all these things. And we will probably, for Seafile, will go for Ceph. We'll continue our testing. Whenever we have something more interesting, we'll try to publish it somewhere. So that's it. Thank you very much.
Thank you very much. Before I open the floor for questions, I am led to understand that the next speaker has not turned up. You have turned up? Yeah. Excellent. You're here. Well, in that case, I'm not going to tell the audience to just fire as many questions as they possibly can. In that case, we'll just restrict it to about 4 or 5.
I owe you a beer.
Owe you a free beer at the reception. Oh, you Polish people.
So what?
You owe me a free beer. Excellent stuff. Questions? You've got plenty of time. There's one. Yes?
Actually, what? Yeah, I could always do this like you proposed, but I think what I did actually, I wanted to compare how the you touched the important point. GPFS actually has potential to be very parallel, but when the results which we see and the difference which we see is also that with GPFS, you've got the cost of keeping the file system consistent, which you don't need in case Seafile actually keep track of consistency. And it only needs a stupid storage keeping blocks. And in that case, object stores make sense. And there's no sense that I install CephFS on top of Ceph and export it to Seafile, because then I'm introducing artificially the file system layer again, which doesn't make sense. It's only slowing down the thing. By the way, it's perhaps not that stable. No, for research and academic.
Are you using it in Anger already? Has it been pushed in front of customers at small scale?
We're having PCNC box at PCNC instance running since almost 2 years, and we are now we're having this Pioneer version, so the rollout made by attaching this service to federated ID system. So those universities that are sign up to Polish Federation, they can have access to the system.
Clear.
You mean Seafile or Ceph? Seafile with the Ceph. No, in this test, we tested 12 clients, so not that many clients, but each having a lot of files. I mean, in each test, we've got 45,000 files tested per one client, and then 12 clients like that. But this large number of users test we didn't yet do. No, they have separate libraries, if I'm not wrong. Yeah, they have separate. For this benchmark, it was easier to have separate libraries. So it's mostly upload download test, actually, yeah, what we did. But we are stressing the purpose was to stress the backend, not that much the synchronization engine.
Right. Towards the back.
Yes, we did this. This reference tests were done with Ceph, how we call it, Rados bench, actually. Rados bench, yeah. That was the reference test which we shown.
The results were that Seafile performed well.
You mean compared to? It was, okay. In terms of files per second, it looks like Seafile is able to use 30% of theoretical Rados performance, but there should be perhaps some tuning down so that I can state this for sure. And we also discussed with the developers already and present here, and maybe there are some ways to improve it. But it's already, even with this 30% ability of to use 30% of IOPS bandwidth of Ceph, it's already much faster than what we can have with the others.
All right, thank you.
Thank you.
One last round of applause, please.